This is the first programming session of Project 5. Let us define the subroutines asked in the first problem of Project 5. That is, the subroutines implementing the encryption and decryption functions. I think you have already downloaded zipped file for this Project 5 on your desktop. Let us start with preparing a necessary folder. Open Finder, then click Home icon, and then double-click CS. Now unzip this downloaded file and move this folder here. Now let us check files in this folder. So for this, let's activate terminal and then go to the room for the Project 5, cdcs/proj5. Okay. Then ls to check the files there. We have 8 programs in this directory. Now for the first program, we in fact make programs for encryption and decryption. Let us see the sample encryption program with the editor. So start code editor. Okay. File open. And then open Home and double-click CS, double-click proj5, and then double-click encrypt.rb. Okay. This is the current encryption program. We need to complete this program by writing this part, the definition of subroutine enc. As we learned, this part is essentially the same as the encryption program enc.rb we created in the last project. Actually, we have this program here in this directory, this folder. So let's open it. Okay, new window. Okay, and then open. And then enc.rb. Okay. Now we copy this part and paste it. Okay, let's modify some statements appropriately. Okay. Well, the shift number and the plain text are given as arguments of the function enc. Okay. So let's erase these 2 statements. Okay. And then let's also remove this statement. This is no longer necessary. Okay. Then instead of this puts command, we use return command to report the answer as a function value. So change it to return C. Okay. Well, we had better give some indentation to each line. Okay, so maybe let me use wider window. Okay. I'm sorry, so too much indentation. Okay. Right. And then this is the end of if statement, and then this is the end of for statement. Okay. And then return. Okay. So from here to here, those indented text is the content of this definition of this function enc. This is good enough for now. Let's execute it. Okay, first save it. And then maybe this is no longer necessary. Close it. And then type Ruby encrypt.rb. Then how about typing hello? Then the encrypted message is obtained like this. Here in this folder directory, we have some sample plain text message. This is the one, message.txt. Let's encrypt it. But before, let us see what is written in this file. For this, type cat message.txt. This is the command to see the content of the file message.txt. Okay, this is it. This is the original plain text. Let us encrypt it. Okay, for this, Ruby encrypt.rb and message.txt. Remember, this is the redirection, okay, for giving an input from input string from the file. So this is it. This should be the encrypted message. Okay, this one. We will check its correctness later. Now let us go back to code editor and create this decryption program. Okay. New window. Okay, open. Well, we also have its template in a folder, decrypt.rb. So let's open it. Okay. So let me make it wider. As you see, the program was already prepared well, which is quite similar to the encryption program. Let us compare them. So first consider the body of the program. Okay, maybe here also the body of the program. So okay, here after the definition, this is the after the definition, the program body starts. In the encryption program, after setting K, the shift number K, the program reads the plain text and transform it to a ciphertext by using this function enc. And then program terminates the execution by showing it on the screen. Okay. The body of the decryption program, decrypt.rb, this is parallel to these instructions. First, K is set to 7. Then the program reads this time ciphertext. Okay, and then transform it to a plain text by the subroutine dec. Then it shows this obtained plain text on the screen. Now consider the function definition. For this, we go back to the top. Here we go back to the top. Okay. Again, the structure is quite similar. The difference is the usage of the variables. While subroutine enc is given an original message as an argument, this is as an argument, and then on the other hand, the subroutine dec is given ciphertext C as an argument. In order to distinguish these situations in these two programs, this program, variable m is used for keeping original message, while C is used for the ciphertext. Of course, such choice of variable names doesn't matter to the computer. We are using these symbols so that we humans can recognize the difference clearly. What is essential is for computing the code of the encrypted character in the subroutine enc. As we discussed before, this is the way to compute the code. We modify the distance dist by adding the shift number k modulo 26. What should we do for the decryption? Well, for the decryption, I would intuitively suggest to do the reverse operation, right? Let us examine what sort of operation is indeed the reverse operation by trying some experimental calculation on the terminal. As we learned before, we can execute a Ruby program interactively. For example, execute the command showing 0 plus 7 modulo 26. Type ruby minus e puts, for example, 0 plus 7 under modulo 26. Okay. Let's execute this command. Then the result is 7. You get the result 7 here. Okay. This means that the letter A, the distance 0, shifted by 7 is 7. The new distance is 7. Okay. How about the letter Y? Recall that the distance from the letter A, the letter Y has a 24 distance from letter A. So B minus E puts 24 plus 7 by shifting 7 under modulo 26. What will be the new distance? Okay. Okay, 5. The answer, this is the answer. This is the new distance of the character that encrypts the letter Y. By the way, the fifth letter in the alphabet is F. So under this shift number 7, Y is mapped to F in the encryption. Now, the decryption here is to obtain the original character from the encrypted character. So from the viewpoint of distance, what we need to do would be the subtraction by 7. For example, distance of Y became 5 for the encrypted code, but now by subtracting 7 under the modulo 26, what can we get? Let's subtract 7 under modulo 26. Okay, ruby minus E puts 5 minus, 5 minus 7 under modulo 26. Okay. You see, we can get 24. Yes, this is the original distance of Y. So this minus 7 under modulo 26, this arithmetic seems like the actual reverse operation. So with this idea, let's complete the definition of this subroutine. So here, what we should do is the reverse operation. Okay, so minus k under modulo 26, right? Sorry again, let me make it wider. Okay, so the actual computation would be like this. Note here that the subtraction should be applied to the distance, that is this dist. Okay, then actual code is calculated by adding the code of letter A, right? So let's run this program. Save. Okay, ruby decrypt.rb. maybe we need encrypted message. Okay, so let's make it first. So let's make encrypted message, encrypt.rb. Why don't we use hello? Okay, so this is the encrypted message, this one. Okay, so let me use this one for decryption. Okay, so just type HLSSB exclamation mark. Okay, you see we got hello, the original message. So it seems like that this program is correct. Let us try with a bit longer message. Okay, we use this example message. Okay, so let me see. So we have this example message, okay, to make an example ciphertext. So Ruby encrypt.rb, then use message.txt, and let's store the result to the file, says c.txt. Okay. Let's see what is stored in this c.txt. Cat, c.txt. Okay, so this is the encrypted message created from the message.txt. So let's decrypt it. Ruby decrypt.rb, and then get input from c.txt, this file. Then we could get back the original message. You see, from this, we can ensure that the encryption program and decryption program both would work. With this, we conclude this session.